Scientists are looking towards artificial intelligence lensing to find masses of free-floating planets. This is from NASA's Goddard Space Flight Center, Julie Frejat on phys.org. They're exoplanets, rogue planets. Now, these exoplanet hunters have found thousands of planets, most orbiting close to their host stars, but relatively few alien worlds have been detected that float freely through the galaxy as so-called rogue planets. They're not bound to any star. So it's not just asteroids and comets that are flying around, it's also these free-floating rogue planets. Many astronomers believe these planets are more common than we know, but that our planet-finding techniques have not been up to task of locating them. So you can imagine how scary this is. Most exoplanets discovered to date were found because they produce slight dips in the observed light of their host stars as they pass across the star's disk from our viewpoint. These events are called transits. NASA's Nancy Grace Roman Space Telescope will conduct a survey to discover many more exoplanets using powerful techniques available to a wide field telescope. The stars in our Milky Way galaxy move, and chance alignments can help us find rogue planets. When a free-floating planet aligns precisely with a distant star, this can cause the star to brighten. And during such events, the planet's gravity acts as a lens that briefly magnifies the background star's light. When Roman may find rogue planets through this technique, called gravitational microlensing, there's one drawback. The distance to the lensing planet is poorly known. Please support my Patreon account since YouTube has again demonetized my YouTube channel. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. Goddard scientist Dr. Richard K. Barry is developing a mission concept called the Contemporaneous Lensing, Parallax, and Autonomous Transit Assay, Cleopatra for short, to exploit parallax effects to calculate these distances. Parallax is the apparent shift in the position of a foreground object as seen by observers in slightly different locations. Our brains exploit the slightly different views of our eyes so that we can see depth as well. Astronomers in the 19th century first established the distances to nearby stars using the same effect, measuring how their position shifted relative to background stars in photographs taken when Earth was on opposite sides of its orbit. It works a little differently with microlensing, where the apparent alignment of the planet and distant background star greatly depends on the observer's position. In this case, 2 well-separated observers, each equipped with a precise clock, would witness the same microlensing event at slightly different times. The time delay between the 2 detections allows scientists to determine the planet's distance. To maximize the parallax effect, Cleopatra would hitch a ride on a Mars-bound mission that launches around the same time as Roman, currently scheduled for late 2025. That would place it in its own orbit around the Sun. That would achieve a sufficient distance from Earth to effectively measure the microlensing parallax signal and fill in this missing information. The Cleopatra concept would also support the prime focus infrared microlensing experiment, PRIME for short, a ground-based telescope currently being outfitted with a camera using 4 detectors developed by the Roman mission. Mass estimates for microlensing planets detected by both Roman and PRIME will be significantly improved by simultaneous parallax observations provided by Cleopatra. Cleopatra would be at great distance from the principal observatories, either Roman or a telescope on Earth, Barry said, and the parallax signal should then permit us to calculate quite precise masses for these objects, thereby increasing scientific return. Stella Ishitavi Silva, research assistant at Goddard and PhD student at the Catholic University of America in Washington, said understanding these free-floating planets will help fill in some of the gaps in our knowledge of how planets form. We want to find multiple free-floating planets and try to obtain information about their masses so we can understand what is common or not common at all, Silva said. Obtaining the mass is important to understand their planetary development. Not only in understanding their development, I would venture to say where they're heading, and hopefully not to us. Now, in order to efficiently find these planets, Cleopatra, which completed a mission planning laboratory study at Wallops Flight Facility in early August, will use artificial intelligence. Dr. Greg Olmshek, postdoctoral researcher working with Barry, has developed an AI called Rapid Machine Learned Triage, RAMJET for short, for the mission. He said, I work with certain kinds of artificial intelligence called neural networks. This is what Olmshek said. It's a type of artificial intelligence that will learn through examples. So you give it a bunch of examples of the thing you want to find and the thing you want it to filter out, and then it will learn how to recognize patterns in that data to try to find the things that you want to keep and the things you want to throw away. Eventually, the AI learns what it needs to identify and will only send back important information. In filtering this information, RAMJET will help Cleopatra overcome an extremely limited data transmission rate, and Cleopatra will have to watch millions of stars every hour or so, and there's no way to send all that data to Earth. Therefore, the spacecraft will have to analyze the data on board and send back only the measurements for sources it detects to be microlensing events. Cleopatra will permit us to estimate many high-precision masses for new planets detected by Roman and Prime, Barry said, and it may allow us to capture or estimate the actual mass of a free-floating planet for the first time, never been done before. So cool and so exciting. Really, it's a new golden age for astronomy right now, and I'm just very excited about it, he said. This is from NASA Goddard Space Flight Center on phys.org. And let's see what they have concerning the explanation from this video. Okay, this is a NASA image microlensing a rogue planet. Unfortunately, there's no audio, but this is their imaging. Please leave your comments. Thank you for your support.